Okay, we're now recording. And let me try to share the screen as usual. All right, so we're doing section 2. Okay, 15 to 22, just the odds, new section. Okay, I think I have about 3 problems to do. Now, don't get your hopes up too high. They tend to be long. Okay, I mean, this assignment looks like it's pretty short, but the reason why it's short is because each problem can tend to get really long. Okay, so I'll lecture on 10.2. Then at the end of class, I'll give you a quiz on 10.1 stuff, and that'll be it. So again, this is a tentative calendar. Move everything up 1 day from the original. So 10.2. So next week, 10.3 and 4. Week after, 11.1 and 11.2. So our next scheduled exam is Tuesday, the 27th. And then assuming I can keep, again, move this up 1 day. I don't want to write it yet, just in case. But if that's 12.1, 12.2, and so on, then our last regular exam would fall on 5/13, it looks like. Okay, and then our final exam is the 20th, and then we're finished with the course. Okay. Right, so on to 10.2. 10.2 incorporates everything from 10.1 and more. So everything we did last time still applies and more stuff. So let's see what that's about. Okay, so 10.2, we're dealing with something called concavity. Whatever that means, I'll have to show you. 10.2, concavity and points of inflection. We already did points of inflection last time for horizontal points of inflection, but not every point of inflection has to be horizontal. So I'll just call them, points of inflection or inflection points in general. That's on page 643 in my book. Okay, and the assignment was what, 15 to 22 odd. So again, let me just show you what the problems were. So my page 652, in case you don't have the book and you don't want to ever get it. Okay, 13 to 18. Find relative maxima, minima. That's the same as last time. Points of inflection, that's new. And sketch the graph. Okay, and I'm going to do more. I'm going to ask you for intervals of concavity, and I'll show you how to do that. So there's 19, 20, 21, 22 also. Okay. Right, so increasing and decreasing, we did that last time. We'll be doing that today on the quiz. And maxima and minima, we did that last time. You'll be doing that in the quiz. Now something called concavity. Okay, on my page 644. Okay, concave up and concave down. Okay, if the graph is curving like a U shape, okay, like this U shape, it's called concave up. Sometimes you think of it as a smiley face. Okay, concave down, upside down U, or maybe a frown type of face. That's called concave down. Okay, easy way to memorize is U for up. You can put this on your cheat sheet or not. I don't think you need to put it on your cheat sheet. Just remember U, right? What does a U look like? Well, it looks like that. So that's concave up. And upside down U, concave down. Okay. Now, what are they trying to show you with these tangent lines? Okay. Well, for concave up, it looks like the tangent line lies below the curve. For concave down, it looks like the tangent line lies above the curve. So that's one way you can characterize concave up, concave down, okay, by the tangent lines. Okay, I think it's easy if you just say U shape up, right? U is up, upside down U is concave down. Okay, but yes, for concave up, tangent lines lie below the graph. Concave down, tangent lines lie above the graph. Okay. So how do you tell if you have concave up and concave down? Okay. So on the bottom of 644, it's based on the second derivative. We haven't talked that much about the second derivative, but the second derivative is simply the derivative of the derivative. Okay. f double prime or y double prime. It's the derivative of the derivative. Okay, so again, put this on your cheat sheet if you wish. Again, if we were meeting face to face, I'd make you memorize it though. Okay, so concave up, second derivative is greater than 0, or second derivative is positive. Concave down, second derivative is less than 0, okay, or it's negative. We won't prove it. If you wanted to see a possible explanation or proof, you might take the other calculus sequence, but for now, we'll just accept it by faith that it works. Okay, so second derivative positive, concave up. Second derivative negative, concave down. So U shape, upside down U shape. It's the way the graph is curved. Right? So how do you do a second derivative? You take a derivative of a derivative, and I'll show you how to do that. In case you're wondering, for today's quiz, you won't have to do that. So today's quiz is just on last time's material. Okay, concave up, concave down. All right, so concave up. Now, neither you nor I feels like writing that whole thing. So let's abbreviate concave up, CU. Okay. Concave down, CD. Okay. Concave up, concave down. Because I don't feel like writing CONCAVEUP or DOWN, just CUCD. Right? So second derivative greater than 0, second derivative less than 0. There's a case that hasn't been considered. Okay, I got greater than 0, less than 0. What's left out? Equals 0. How about equals 0? That's where you might have a point of inflection or inflection point. Okay, so I'll abbreviate inflection point. Okay, IP for inflection point. Okay, but what really is an inflection point? Page 645. A point is a point of inflection or inflection point if the curve is concave up on one side of the point and concave down on the other side. The second derivative will be either 0 or undefined. Okay, so that means the graph switches, it transitions from being concave up to concave down or vice versa. Okay, and I'll try to show you an example from a graph. Okay, inflection point. Let's take a look at this graph here, which is computer generated. Okay, maybe right around there. This looks like it's concave down, right? It's upside down U shape. And then maybe the rest of the time that looks like it's concave up, U shape. So right when it transitions from concave up to concave down or vice versa, that's called an inflection point. Okay, so offhand, it graphically looks like it may be somewhere over here for the inflection point. Point of inflection. Okay. Right, so we're going to analyze graphs like that. So let me show you some other graphs that we have. Okay, so on page 646, again, concave up, U shape, concave down, upside down U shape, concave up, U shape. That means the second derivative, let me raise it up, second derivative is positive, second derivative is negative, second derivative is positive. Okay, that means we have an inflection point right here and right here. Okay. Here's a graph on the bottom of 646. Here's an inflection point. Okay. Concave up, concave down. Okay. I'll just say this in passing, but in economics and sometimes in scientific applications, that point after the inflection point is sometimes called the point of diminishing returns. Okay. So the graph is still going up. Notice how it goes up fairly sharply and then it levels out. So you're still increasing, but not as much as it was before. Okay. So that's considered a point of diminishing returns at your inflection point. Okay. So what's going to happen in this section? I'll be doing quote unquote only 3 problems, but that's not short. We're going to do maxima and minima, 649. Again, maxima and minima is the plural of maximum and minimum, right? One maximum, two maxima. We're not supposed to say maximums. One minimum, two minima, and inflection points, or points of inflection. Okay, we did this last time. Your quiz today will be just this. But the new stuff that we're going to analyze is points of inflection. Okay, now maxa and minima were from the first derivative. We have to take the second derivative to get points of inflection. And I'll be showing you how to do that now. Okay. All right, so without further ado, here we go. Okay, as usual, I'll do evens. I was only going to do 3 problems, but again, that doesn't mean it's short. Okay, so find relative maximum, minimum, points of inflection, sketch the graph. Okay, I'm also going to include intervals of increase and decrease, which I want you to know how to do. And I'll show you that also. Okay. All right, so my problem 16 from previous edition is x cubed minus x squared. Okay, so analyze it for maxima, minima, points of inflection, intervals of concavity, all that stuff. Okay, so the usual thing you want to do is start off by taking 2 derivatives. Okay, so y prime is 3x squared minus 2x. That's easy. The second derivative is also easy, 6x minus 2. Right? So what's the second derivative? It's the derivative of the derivative, right? When you take a derivative, the thing that you get back is another function, which means you can take another derivative. Okay, so here's x cubed minus x squared. First derivative, 3x squared minus 2x. Second derivative, 6x minus 2. Okay, now set the first derivative equal to 0. Okay, so 3x squared minus 2x equal to 0. We are also going to set the second derivative equal to 0. Okay, but right now, all of this stuff is what we did last time, and that's what you're going to do in the quiz. Okay, set that equal to 0. Factor out the x. X times 3x minus 2 is equal to 0. So by the 0 factor property, either this one is 0 or this one is 0. So x is 0, that's finished. 3x minus 2 equals 0, a little bit of algebra. Add 2, divide 3, x equals 2/3. So my critical numbers are 0 and 2/3. So what are critical numbers? That's where the derivative is 0 or undefined. This expression is never undefined though. It might give me maxima or minima. All right, plug back into the original. Plug in 0 is easy. 0 minus 0 is 0. What's not so nice is 2/3. Okay, so what do you get if you plug in 2/3? It's 2/3 cubed minus 2/3 squared. 2/3 cubed, 2/3 times 2/3 times 2/3. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Minus 4/9. Common denominator is 27. So that's going to be 8 minus 12, or negative 4 over 27. Okay, so I have 0, 0, and 2/3 negative 4/27. Okay, up to now, this is exactly like last time. No difference. Okay. Now I do a sine chart, just like last time. Okay, so draw my number line, 0, 2/3. Okay, when I plug in 0, I get 0. When I plug in 2/3, 3 times 2/3 is 2. 2 minus 2 is 0. Okay, so if I plug in 0, I get 0. Plug in 2/3, I get 0. Those are the only places where I get 0. That means everywhere else I do not get 0. Well, if you're not going to get 0, you're either going to get a positive or a negative. So just determine the correct sign. That means I pick something over here, over here, over here. That's just like last time. That's just like the quiz today. Okay, so I'm setting you guys up for the quiz, per se. Okay, so what's the number over here? Well, negative 1. Okay, what's a number between 0 and 2/3? There aren't any nice numbers, so I just picked 1/3. I guess you could also pick a half, but I think a third is okay. And then to the right of 2/3, 1. Okay, again, I only need a sign. So negative 1 is negative. Plug in -1. 3 times -1, -3 minus 2 is also negative. So I'm going to have a negative times a negative, which is positive. So positive. Plug in 1/3. 1/3 is positive. 3 times 1/3, 3 times 1/3 is 1. And then 1 minus 2 is a negative. So I'm going to have a positive times a negative. That's a negative. So minus sign right here. And then I plug in 1. 1 is positive. 3 times 1 is 3. 3 minus 2, positive. Positive times positive, positive. Okay, so first derivative positive means increasing, increasing. Negative, decreasing. So I have my intervals of increase and decrease. So far, this is exactly like last time, and it'll be just like this for the quiz. So f is increasing from negative infinity to 0, union 2/3 to infinity. F is decreasing from 0 to 2/3. Then the U stands for union, U-N-I-O-N, union, you're joining more than one set. All right, here we go. The roller coaster ride goes up, goes down. What does it mean about this point? Maximum. 0, 0 is a relative max. Sometimes we say local max. Okay, how about at 2/3? The roller coaster goes down, then it goes up. Well, if you go down, then you go up, you got a minimum. So 2/3 comma -4/27 is now a relative minimum. Okay, so up to now, that's exactly like last time. So if you have the graph not considering concavity, the graph goes up to 0, 0. There it is. Then it goes down from 0 to 2/3, goes down to 2/3 comma -4/27. Ignore this inflection point for the time being. After that, it increases, it goes up. Okay? That's what you're required to have for today's quiz. So right now, all of this is old stuff. Now for the new stuff, second derivative analysis. You basically do the same thing. So you know how we set y prime equal to 0? Okay, everything here is just like last time. Now you do the same thing for y double prime. Set y double prime equal to 0. So my second derivative was 6x minus 2. 6x minus 2, make that equal to 0. A little bit of algebra, add 2, divide 6. X is 2, 6, which is 1/3. Okay, so my critical number for the second derivative is 1/3. Now I need the y coordinate. Okay, y coordinate, go back to the original. So plug in 1/3, that's not very nice. 1/3 cubed, 1 is 1/3 squared. 1/3 cubed, 1/3 times 1/3 times 1/3 is 1/27. Minus 1/3 squared, 1/3 times 1/3 is 1/9. Okay, common denominator is 27. So multiplied by 3/3. So my common denominator is 27. I got 1 minus 3, which is -2. So the point is 1/3 comma -2/27. Okay, so 1/3 -2/27. This is not to scale. Okay, y coordinate of 0. Here's -4/27. -2/27 is between the two. Okay, now you know how we did the sine chart for the first derivative? Do the exact same thing for the second derivative. Okay, so y double prime was 6x minus 2. I laid down the point where the second derivative was 0, namely 1/3. That's the only such place. Okay, quick double check. What happens if I plug in 1/3? 6 times 1/3, or 6 divided by 3 is 2. 2 minus 2 is 0. And nowhere else do I get 0. That means everywhere else is either positive or negative. So just determine what's the sign. Okay, so I picked something less than 1/3, 0. Pick something greater than 1/3, 1. Okay, plug in 0. 6 times 0 minus 2, -2, that's negative. 6 times 1, 6 minus 2, positive. Okay, now, however, we're doing the second derivative. Second derivative negative, concave down. Upside down U shape. second derivative positive, concave up. So my page 644. Concave up, second derivative positive, greater than 0. CU. Concave down, CD, second derivative less than 0, negative. Second derivative negative, concave down. Second derivative positive, concave up. So here are the intervals of concavity. So you know we had intervals of increase and decrease, right? Where is it going up? Where is it going down? Now we have intervals of concavity. The function f is CD, concave down, from negative infinity to 1/3. It switches to concave up from 1/3 to infinity. There is a change in concavity, so I do have an inflection point. Okay. My abbreviation for inflection point, IP, is inflection point, 1/3, -2/27. So now, finally, after all that analysis, here's the graph. Okay, just from last time, up until 0, increasing to the origin, between 0 and 2/3, decreasing, then from 2/3 on, increasing. Concave down from negative infinity to 1/3. So upside down U shape right here, from negative infinity to 1/3. And then the rest of the time from 1/3 to infinity, it's U shape, concave up. And there we go. Please notice concave up and concave down doesn't have anything to do with increasing and decreasing. They're completely different concepts. Okay, so there we go. And let me raise this up for focusing purposes. So all of that we've done so far was just one problem, problem 16. All right. Okay, so next one I was going to show you was 18. Okay, x cubed minus 3x squared plus 6. All right, so same thing, take two derivatives. Y prime, 3x squared minus 6x. All the first derivative analysis is exactly like last time. So that's old hat for you, and your quiz will be that. So we're kind of preparing for the quiz also. Second derivative, 6x minus 6. Set y prime equal to 0. That's just like last time. 3x squared minus 6x equals 0. Factor out 3x. 3x times x minus 2 equals 0. So what number makes 3x equal to 0? Well, 0. What number makes that 0? 2. So my critical numbers are 0 and 2. Plug in to find the y coordinate. So what do you get when you plug in 0? 0 minus 0 plus 6, 6. So 0, 6. Plug in 2, it's a little bit harder. 2 cubed is 8. Minus 3 times 2 squared, 3 times 4 is 12. Plus 6, that comes out to be 2. So my critical points are 0, 6, and 2, 2. Sine chart. 3x times x minus 2. What do I put on my number line? Wherever the derivative was 0. That happens at 0 and at 2. So pick something over here, -1. Something here, 1. Something here, 3. And again, I just want the sign. Plug in -1. 3 times -1, negative. -1 minus 2, negative. Negative times a negative, positive. 1. 3 times 1, positive. Notice I don't care about the exact value. I just want the sign. 1 minus 2, negative. Positive times a negative, negative. And finally, plug in 3. 3 times 3, positive. 3 minus 2, positive. Positive times a positive, positive. Okay. Positive first derivative, increasing. Negative, decreasing. Positive, increasing. So intervals of increase and decrease, f is increasing from negative infinity to 0, union 2 to infinity. F is decreasing only between 0 and 2. All right. So you're driving, you go uphill, then you go downhill. What does that make this point? Relative maximum. How about you go down? I mean, you could be roller coaster or driving or walking. Okay, you're walking down, right? Walk down the hill, then you go back up. That point must be a minimum, right? So 2, 2 is a relative minimum. Again, that's like last time. And again, that's like the quiz I'm about to give you later. So here we are, 0, 6, maximum, 2, 2, minimum. We don't know about this inflection point stuff yet, so we'll get to that later. New stuff, second derivative, which controls concavity. Set y double prime equal to 0. So my second derivative was 6x minus 6. Set that equal to 0. A little bit of easy algebra, x is 1, right? Add 6, divide 6, x is 1. Find a y coordinate. So f of 1, plug in 1. 1 cubed is 1, minus 3 times 1 squared is 1. So 1 minus 3 plus 6, that's 4. So 1, 4. All right, then on my number line, I place down a 1, y1, that's the only critical number. Pick something over here, something over here. Okay, and you can't really see what I have there, but a number over here is 0, number over here is a 2. Those are very easy to compute. Plug in 0. 6 times 0 is 0. 0 minus 6, negative. Plug in 2. 6 times 2, 12. 12 minus 6, positive. Okay, so again, negative second derivative, concave down. Positive second derivative, concave up. Was there a change in concavity? Yes, there was. So I have an inflection point at 1. So here are the intervals of concavity. F is concave down between negative infinity and 1. Concave up from 1 to infinity. Right? Negative infinity to 1, concave down. Rest of the time, concave up. And I do have an inflection point at 1, 4. So here's the entire graph. Okay, so we said this is a max, this is a min. Let's see, the first derivative analysis went increasing, decreasing, increasing. So increasing up to the max, decreasing down to the min, increasing after that. Okay, concave down from negative infinity to 1. So right here, upside down U shape. After that, concave up, U shape. So that makes this an inflection point. And you can imagine such a roller coaster ride, right? For those of you that like roller coasters, right? Goes up here, reaches a maximum, starts to go back down, reaches an inflection point, goes to a minimum, and then goes back up. Okay. All right. As you can probably guess, there's a lot of good mathematics in roller coasters. You know, obviously, when you go to an amusement park, you don't think about this stuff, but people behind the scenes, when they build roller coasters, right? Where do we want the ride to go up? Where do we want it to go down, right? Maximum, highest point, lowest point, right? Slope is 0, slope is 0. Inflection point. Okay. At an inflection point, that's, if you like roller coasters, you get a certain sensation there. You kind of feel like you're pushed in it. For you roller coaster, you know, buffs, when you're at this point, you kind of feel like you're switching over and you kind of go, whoa, right? And it kind of now drives, the roller coaster drives you down a little bit more. That's what's happening at that inflection point, so to speak. Okay. All right. Then last one I was going to show you was 22. And they were very kind for this one because It came up very tough otherwise. Okay, x to the 5th minus 5x to the 4th. All right, so f prime, they actually gave you all of this. I'll show you. From 22. Oh, it's actually, they were nice enough. It's 20 here, but they gave you f prime and f double prime. Okay, but they didn't have to. But they give you the factored form. Okay, here, I'll show you. What's the derivative of this? 5x to the 4th minus 20x cubed. Okay, so if you factor out the 5x cubed, you have 5x cubed times x minus 4, right? The second derivative, well, what's the derivative of this? 20x cubed minus 60x squared. And then if you factor out the greatest common factor, which is what? 20x squared, then you have x minus 3 left. Okay. All right, so otherwise just do the same stuff. Set f prime of x equal to 0. So 5x cubed times x minus 4 equals 0. So either x is 0. You know, how do you make 5x cubed 0 when x is 0? And how do you make x minus 4 0 when you plug in 4? Okay, plug in 0, you get 0. That's very easy. 0 to the 5th is 0. 0 to the 4th is 0. 5 times 0 is 0. 0 minus 0 is 0. Okay, so 0, 0. What's not nice is 4. Okay, so plug in 4, you get 4 to the 5th minus 5 times 4 to the 4th. Okay, you can punch all that out. You know, take my word for it. I guess it's negative 256. Now, certainly when we graph it, we're just going to plot it down. You know, no one wants to count 1, 2, 3, 4, 5 all the way down to negative 256. So, you know, just generally put it where it belongs. 4 comma negative 256. Okay, sine chart. Intervals of increase and decrease. Again, that's just like last time. That's just like the quiz that I'm about to show you. Okay, so pick something here, here, and here. So negative 1, 1. You could pick 2, you could pick 3. I like 1. 5. You could pick 6, you can pick 8, you can pick 1,000,000. I like 5. Okay, plug in 5 times negative 1 cubed. Negative 1 cubed, negative 1 times negative 1 times negative 1 is negative 1 times 5, it's negative. Negative 1 minus 4, negative. Negative times negative, positive. Okay, plug in 1. 5 times 1 cubed, positive. 1 minus 4 is negative. See how much nicer it is when you don't care about the exact value, you just want the sign. All right, so I'm going to have a positive times a negative, which is negative. 5. 5 times 5 cubed. Well, I don't really care about the exact value. That's a big number, but I know it's positive, right? 5 minus 4, positive. Positive times positive, positive. So again, just like last time, positive first derivative, increasing, increasing. Negative first derivative, decreasing. So f is increasing from negative infinity to 0, union 4 to infinity. F is decreasing only between 0 and 4. If your roller coaster goes up and then it goes down, what do you have at this point? Maximum. 0, 0 is a relative max. That's REL there. If you go down, you're riding a bus. It goes down, then it goes up. Minimum. 4 comma negative 256, relative minimum. Okay, so if I temporarily ignore concavity, here we are. Up, down, up. Maximum, minimum. Increasing from negative infinity to 0. There it is, up to 0. Then between 0 and 4, decreases down to negative 256. And after that, from 4 to infinity, roller coaster goes back up again. Okay, so that's the first derivative analysis, same as last time, same as the quiz that I'm going to give you shortly. New stuff, f double prime equal to 0. Okay, so my double prime was where? Where did it go? 20x squared x minus 3. Set that equal to 0. What makes this 0? 20x squared, 0. What makes this 0? 3. 3 comma negative 162. Okay, so 3 goes back to the original. It's 3 to the 5th power minus 5 times 3 to the 4th power. You can punch that in. 3 to the 5th minus 5 times 3 to the 4th comes out to be negative 162. All right. Do my sine chart for f double prime. 20x squared times x minus 3. Okay, I lay down the two numbers where the second derivative was 0, 0, and 3. Pick something over here, negative 1. Pick something here, 1. Pick something here, 4. Now, take a look at this though. 20x squared. As long as I'm not plugging in 0, which I'm not, plug in any other number, positive or negative. What do you know automatically about 20x squared? Automatically positive, right? So all these pluses reflect the 20x squared already being positive. Okay. So the sign is going to be completely determined by x minus 3. Okay, so plug in negative 1, negative 1 minus 3, negative. So positive times a negative, negative. Plug in a positive 1. 1 minus 3, negative. Positive times a negative, negative. And plug in 4. This is already positive no matter what I plug in. 4 minus 3, positive. Positive times a positive, positive. So intervals of concavity. The function f is concave down, CD, from negative infinity to 0, union 0 to 3. Strictly speaking, I'm not going to say it's concave down at 0 because the second derivative was 0. Function's concave up from 3 to infinity. Okay, but now here's our first case where the second derivative is 0, but we do not have an inflection point. In order to have an inflection point, the concavity has to change either from concave down to concave up or concave up to concave down. That did not happen over here. So I do not have an inflection point here. How about at 3? Is that an inflection point? Yes, it is. It switched from concave down to concave up. So my only inflection point is 3 comma negative 162. I do not have an inflection point at 0 because it was concave down on both sides. Okay. So to emphasize that again, let me show you what it says in the text about inflection point. Okay, so on my page 645, point of inflection or inflection point. A point x0, y0 on a graph is called a point of inflection or inflection point if the curve is concave up on one side and concave down on the other side. So it switches from concave up to concave down or vice versa. That did not happen over here. Right? Concave down on both sides. So technically, we do not have an inflection point here. We have an inflection point right here. All right, so we're ready. So this is obviously not the scale. So 0, 0 is a max. 4, negative 256 is a min. 3 comma negative 162 is an inflection point. Okay. So increasing, decreasing, increasing. Increasing to 0 reaches a max. And then it decreases to 4. Roller coaster goes down to here. reaches a minimum. And then for forward infinity, the roller coaster goes back up. And then for concavity, concave down, concave down. So upside down U shape until I reach 3. Upside down U shape. Then from 3 on, concave up, U shape, the rest of the way. So there we go. Okay, so I'm done, folks. Let me do my focusing thing real quickly, in case you couldn't see any of that. And then if there are no questions, I'll go ahead and give you the quiz. And we still have about half an hour left, so you should have plenty of time to do the quiz. So, focusing thing. And then over here also. And there's that. Okay. All right. So that's that. Anybody have any questions? Otherwise, we're done for today. So I'm finished with section 2. Next time we will do section 10.3. Okay. And then, so I guess Tuesday, Thursday, 10.3, 10.4, then the following Tuesday, Thursday, and then after that we have a test. Again, doing a 1 section a day. Okay, any questions, please? Okay, I don't see or hear anything, so let's go straight to the quiz. All right, so get your cell phones out. I'll be ready to do a screenshot. And then get started, and I'll set you into your breakout rooms. Okay, the function is f of x equals x cubed minus 3x squared. Okay, you do not have to do the second derivative analysis, just the first derivative analysis. So find the critical points, then use a Sine chart to determine if the points are relative maximum or relative minimum. Okay, so the function again is x cubed minus 3x squared. Okay. Again, I'll say I have no idea what to do. Take the first derivative, set it equal to 0, find your x values, right? Do your Sine chart. Based on a Sine chart, determine if you have a maximum or a minimum. Okay, I'll hold it just for another 10 seconds maybe, and then I'll assume that everybody has it. Then I'll say it again, it's x cubed minus 3x squared. That's really all you need, x cubed minus 3x squared, right? F of x. Okay. Determine maxima and minimum points. Okay, I will now assume everybody has it. So go ahead and get started. I'll set up your breakout rooms. Okay. All right, Hugo, I got you. Let's see, Caitlin, can you send me an email, please, if you don't mind, about that, then I can get that for you. All right. All right, so get started. Let me set your breakout rooms.